This is George from linuxdojo.com, and today I'm going to show a quick demo and overview of Evon Hub, what it is and how to use it. So Evon Hub is an open source overlay network tool. You can find it here at evonhub.com or on GitHub. Evon Hub could be thought of as a private physical network hub into which you can connect your devices and servers, but it uses a VPN to connect to the hub rather than physical cables. The hub itself is private and accessible only to users that have an account set up by the owner. So systems on the hub can communicate with each other based on network permissions. So as such, the hub can be used for things like remote desktop, SSH access, private intranet sites, as well as things like server management and monitoring and orchestration and the like. Basically anything that you can do over a normal network or LAN. So Evon Hub uses OpenVPN under the hood to connect systems together. OpenVPN is a well-established open source secure VPN. While it's not as fast as more modern alternatives like WireGuard, it does have a few advantages that can help some people, including looking similar to HTTPS traffic. So that is SSL over TCP port 443. And that means that you can connect systems to your hub that are behind fussy network firewalls or behind web proxy servers and the like, and it's quite useful for that alone. So without further ado, let's have a look at the hub and what it's like using it. I'll just sign in off the website. I'll just log in using email. You can use Google or GitHub as well. I'll grab my OTP, chuck it in, and we're logged in. So this is the hub dashboard. This is what you'll see after you subscribe and deploy a hub. You can deploy a hub in one of many countries. You get your own VPS when you deploy a hub, a dedicated virtual machine. And these are some statistics at a glance stats about the hub. Each hub has got an FQDN. This particular one has got this one here, linuxdojo2.even.link. If I click it, it'll take us to the login page. So I've got one pre-baked here. I'm going to log in. And this is what it looks like when you actually log into your hub after you've deployed it. After you've signed up, subscribed, and deployed a hub and logged in, this is what you'll see. And it's here that you set up servers. For example, clicking on the servers nav will show you, in this example, 8 rows. Each row represents a computer or a system that's connected to this hub. Some are Linux, some are Windows. They can be any OS that supports OpenVPN. And of course users, these are the humans that can access the hub and access a subset or maybe all of the systems that are connected to this hub. Access between users and servers, as well as servers to other servers, is governed by rules and policies. And a quick glance at them here, you can see that rules define sources, destination protocols and ports, and policies glue rules to actual targets. In this case, a single server, Jupyter, no target server groups. The allowed source is a user by the name of Benjamin, and they are allowed to apply these two rules. One's called allowed ping, so it must be ICMP. You can ping Jupyter. One squid access, that must imply that he can access Jupyter and port TCP port 3128. Drilling into a rule, you can see indeed that's what it is, TCP port 3128 for the source user Benjamin. How do you connect the server to the hub quickly? You click on Bootstrap and you can see instructions. So even Bootstrap is a script that connects a server to your hub. So you can connect a Linux machine to the hub, a Windows machine to the hub. You can connect a system to the hub using Docker, or you can just grab the raw OpenVPN file and use that to connect a machine to your hub. So this is how you might connect something like an OS X box or a tablet or a phone or whatever device, anything that can support OpenVPN. Just use this file, download it, and just click it to download it. There she goes, and connect your device to the hub. It'll appear in this server list. These are monitored constantly for health. All these are green lights and healthy. Last seen now. If a hub disconnects because it falls off the internet, it will automatically reconnect. There's an infinite retry on the OpenVPN client configuration that ships out to it, and it'll just come back online when it can reconnect to the hub. Every machine gets a static IP address and a publicly resolvable, fully qualified domain name, DNS name here. So Jupyter.linuxdojo.even.link is globally unique on the internet, and it will resolve to this private address here. So the only way you can reach it is if you're connected to this hub, if you're authenticated and connected to this hub using a user. And as a human, as a user, you click on OpenVPN client and download the OpenVPN configuration file for your desktop or your tablet or your phone. So if you're on Linux or Windows or Mac, you'd use one of these. If you're on mobile, or if you just want just give me the damn config file, you can grab it here. There's a few hints on this page as well, how to list servers on the hub. This is kind of tailored for CLI power users. There's some script snippets that you can paste in and get visual listings of things on the hub. For example, get this server list at your command line for convenience sake. Every function in this UI is exposed via an API. If you click the API developer docs here, you'll see a Redoc generated API documentation page. Something familiar to most programmers, and as mentioned, everything that's available in the UI is available via the API. So let's drop to the shell and have a look at some of the things that we can do. So there's a shell, and so running that script that was shown reveals this, an inventory of nothing. So that means that there's no rules that have permitted this particular user, us, the George M user, that I'm logged in as, access to any service. So if I'll demonstrate how to apply a policy for that. So we go add policy. Policy name is full access to all systems. I'll give that to myself. The rules, there's an allow all rule. The target server groups is the all servers group. I'll save that. Done. Now, as you can see, I'm allowing all. Click at the allow all source. You can see that it's any protocol for the source user, just George M, me, who's logged in. And the target service is all servers, so all of those 8. So now if I go and rerun this command, I'll see all 8 available, and I can do things with them. What am I permitted to do? Anything, because it was any protocol. I'm not constraining myself to ports and protocols, so I can ping one at random, ping Atlas, and you can see it resolves to the public name, to a private IP address. The public name resolves to a private IP address that's only reachable if I'm connected, authenticated to the hub. So what else can you do? Most of these are Linux boxes. I know this one here is a Windows box. Let's SSH to some Linux boxes. So for the inventory, short list will only provide the rightmost last column. I'll grab I'll just shrink the list to 3 boxes. Say Jupiter, Europa, and Callisto, for example, should be 3 rows. And I'll connect to them all via SSH. Go, and now I'm SSH'd into those 3 that were returned. Jupiter top left, Europa, and Callisto. This is just Tmux with multiple panes and pane synchronization enabled. So it's like a poor man's orchestration tool. You can type in one and have multiple cursors, but you can DNF update, for example, or whatever you wanted to do across all the machines. One other example, so this Windows box I know is running VNC Server, so we can use VNC Viewer against it and connect to it. This is all happening over the hub. So, and here we can see, I'm on a Windows machine, etc. I'll disconnect from that. All via the hub. And that is it in a nutshell. Thank you very much for watching. There'll be subsequent videos with deeper dives on how to connect servers and do other functions via Evon Hub. And if you're interested, go take a look at it at evonhub.com. Thanks very much.